Alright, Unit 20, Day 4, Adding and Subtracting Radicals. So, the cool thing about today is that you're not really technically learning anything new, which is kind of cool. We're just compounding two different skills that y'all already have and compressing it into one skill. So, the thing is, all that we're doing is we're combining our combining like terms skill with the skill that we've been working on for the last couple of days, which is simplifying radicals. So if we look at 1 through 3, all those is just basic combining like term problems. Okay, on number 1, you notice that we have an x term on both of those, or a variable of x on both of those, and then 2x plus 3x is going to be 5x. A good way to think about it is 2 apples plus 3 apples is 5 apples. Okay, now on 2, okay, we've got two different things going on here. We've got 4w squared and 5w squared, which is going to combine to give me 9w squared. And then we're going to subtract the 8w. Okay, good math grammar dictates that we put the biggest exponents at the front, smaller exponents at the back. Just the way it works. Okay? Now, number 3. Okay, we're going to combine the 7x squared y and the negative x squared y, and that's going to be 6x squared y. And then we're going to have negative 2y plus 3y. Well, that's just going to be plus y. And that's done. And it's that easy. Alright? Now, the next little section here, okay, we got adding and subtracting radicals. It's similar to adding or subtracting like terms, it's exactly like I just said. Alright, now, we're going to have a and c, and then we add the a and the c only if the square root is b on both of them. Now, that's just kind of a fancy way of saying that we have to have the same thing under the radical in order to add these two things together. Okay. Second thing is, you basically treat the a and the c as coefficients almost, and we just add the coefficients together. Alright, same thing goes for our subtracting. Okay, we're going to just subtract them like they're coefficients. Alright, now the major rule of today, okay, is that this will only work if you have the same thing under each of the radicals. Okay, radicals are that funny looking division sign. It looks kind of like that. Alright, now let's go ahead and move on to some of these problems here. So on number 4, things are cut and dry, pretty simple. We have the same thing here as we do there. 3 plus 4 is 7, which is 7 roots of 2. Alright, number 5, same exact thing. Just you gotta make sure that you put that 1 out there in front of that square root 3. Okay, I even do it just to help remind myself that that's actually there. So 7 roots of 3. And there it is. Now, number 6. Okay, same concept, same thing. We're just going to keep going with the flow here until we hit something that's kind of rocky. 14 minus 6 is 8. 8 square root 3. And that's done. Alright, okay, on number 7 we have the exact same thing under each of these. Square roots of 5. So 5 minus 1 is 4. 4 plus 8 is 12. So we got 12 roots of 5. And that's done. And it's that easy. Okay? Now, number 8, we run into a little bit of a roadblock. Okay? We notice that we have square root 3, square root 3, square root 2's, square root 2's. No big deal. Okay? We're going to combine those two and combine those two. So 3 plus 4 is 7. So 7 root 3. And then we're going to go negative square root 2 plus 6 square root 2, which is going to be 5 square roots of 2. And there it is, okay? And usually I'll put the biggest roots at the front, smaller roots at the back. Okay? On number 9, Okay, we run into a little bit bigger of a roadblock. Now, as you can see, square root 12 and square root 27 are two very different things. Or at least they appear to be. Okay? But what we need to do is simplify these. Now, in order to simplify these, all we do is we break apart that 12. And we go 3 and 4. 4 breaks apart into 2 and 2. There's our pair. Couples go out. Singles stay home. 2 square root 3. Okay? 27 breaks apart into 3 and 9. 9 breaks apart into 3 and 3. There we go. There's a couple. Couples go out. Singles stay home. Alright, now, the thing is, that right there is really the square root of 12. Okay? This is really the square root of 27. Okay? And you just got to keep that in mind, okay? So, 2 minus 3 is negative 1. So, that's negative 1 square root of 3. And that problem is now officially solved. Okay? And you just leave it like that. Okay? Number 10. Okay? We've got 8 plus, or rather, the square root of 8 plus the square root of 18. Okay? Same exact process as number 9. Okay? We're going to break apart this 8 here. And that's going to be 2 and 4. 4 breaks apart into 2 and 2. Okay? 18 breaks apart into 2 and 9, which breaks apart into 3 and 3. So on this piece, we can go 2 on the root of 2. And on this one, we're going to break off the 3's and go 3 on 2. I'll fix that real quick. There we go. 3 on the root of 2. And that's going to be 5 roots of 2. And that problem's finished. Right? Now, number 11. Okay? Again, the exact same process. Okay? We break apart the 24. That's going to be 2 and 12, which is 2 and 6, which is 2 and 3. Get your pairs. So that's 2 on the root of 6. Okay? And that's 54, which is going to break apart into 2 and 27, which is 3 and 9, and that's 3 and 3. And there it is. Okay? So we're going to subtract 3 roots of 6 from that one. And that's going to be negative 1 on the root of 6. Okay? Now, if y'all are having trouble with where I got the 6 from, well, you might want to go back and check the other videos, days 1 and or days 2 and 3. Okay? All right. Now, moving along here with the number 12. Okay? We've got a 48 to break apart, and the 48's really easy to break apart. That's just going to be 2. I'm going to break that into a 4 and a 12 instead. Okay? And something that y'all are going to start figuring out is that there are better ways to break these apart to where you don't have to take so many steps. Okay? And we got 4 and 3, and now I have a pair. So I can go 4 roots of 3. Alright? Now 18, I can break apart and go, let's go 3 and 6, which is 2, or rather 3 and 2. There's my pair. So, now if you remember correctly, when I simplify these, I have to multiply the number that's outside by the number that's inside. So that's going to be minus 6 roots of 2. Okay, now I need to break apart the 12 and go 3 and 4, 2 and 2. So I'm going to pull out the 2's, multiply them by that 3 on the front, which is going to be 6 roots of 3. So 4 root 3 plus 6 root 3, that's 10 root 3, minus 6 root 2. And there we have it. That's the end of that problem. And it's that easy, y'all. Okay? Alright, next page. Okay? Now these questions are just as easy as the stuff on the front, even though they have a variable in there. Ooh, scary. Okay, they're not really that scary. Okay, we just treat them just like we have been for the last few days. So with the 32x, okay, well, the x is a single, so we're just going to leave that inside of the radical down at the bottom. That's just going to happen, okay? 32, I'm going to break that into 2 and 16, which will break apart into 4 and 4, which I can pull out the 4s, and that's going to be 4 roots of 2x. And then we're going to break apart the 8 and get 2, 4, 2 and 2. And that's going to be plus 2 on the root of 2x. 50 breaks apart into 2 and 25, which breaks apart into 5 and 5. Okay, and that's going to make me pull out a 5 and leave it on the root of 2x. Now, if you'll notice, all of my radicals are the same thing. Okay, and if you reduce it correctly, 9 times out of 10, you will wind up with the same thing under your radicals, or at least you'll have some kind of matching pair somewhere. Okay? Now, 4 plus 2 is 6. 6 minus 5 is 1. So we're left with just 1 square root of 2x. And there it is. Alright, now, number 14. I'm starting to kind of go off into other territories here. Oops. Okay? Now, the 54, okay? I'm going to break that apart up here, so that way I have some room. Uh-oh. No. There we go. 54. Okay, so that's going to be 6 and 9. The 9, okay, 6, as we found out earlier, doesn't really make anything nice for us to break apart. So we got a 3 and a 3. Okay, so we can pull that out and leave it as 6. Whoops, almost did that backwards. 3 root 6. Alright, now the 128 will break apart into 2 and 64. So I got 2 and 64 as that one, and that'll break apart into 8 and 8. Okay, there's a pair. So I got 8 roots of 2. And there's the answer. And it's that easy, okay? Now, 15 is about as easy as they come, okay? All you gotta do is be able to recognize that this is just the opposite of that. Boom, boom, gone. 6 root 6. Or 6 root x. Oops, sorry. I keep on misspeaking, I apologize. Alright, so number 16, it says to find the perimeter of the triangle. Give your answer as a radical expression in simplest form. Now, 5 root 7 is already as far down as it'll go. You can't break 7 apart, it's prime. Okay? Prime meaning that the only way to get 7 is by multiplying it by 1, basically. Or multiplying itself by 1. Okay? Now, 28, on the other hand, we can break that apart, okay? And whenever we do that 2 and 14 and 2 and 7. So there's that, and then we can go 2 on the root of 7, okay? Now, that is the equivalent of saying square root of 28, okay? Now, what we're going to do with this is we're going to go 2 root 7 plus 5 root 7 plus 12. Okay? And most of y'all are going to go, oh, ooh, that's 19 root 7. No. Don't do that. Okay? Bad student. Now, what we're going to do instead is we got square root 7 and square root 7. Okay? 2 plus 5 is 7. So we got 7 roots of 7 plus 12. And there we have it. Okay? And that's the end of the notes. All done. In less than 15 minutes. Alright.